A bouncing ball can be the source of a lot of intrigue, and not just to the athlete or sports fan, but to the people in the science community as well. We geeks got game too. And we might just play a little bit differently sometimes. And we have better equipment like this Passport motion sensor, because we might know just a little bit more about the potential of a bouncing ball than Joe Jock might. We're going to show you how to use your xploer GLX to perform mathematical operations on the position and velocity information we obtain from this sensor so that we can study the gravitational potential energy and the kinetic energy of this bouncing ball. Now, just like in any other game, besides having great equipment, you might need to have some great teammates, and I brought in a ringer. Now, if you have a couple of rods, you'll want to set it up like we have here. If not, you'll probably want to recruit a third team member to hold your motion sensor for you. If you are using the rods, you will want to put them through these holes on the motion sensor and then secure the sensor to them using this thumb screw. Also, you'll notice that there are two settings on the top of your motion sensor. Make sure that you have it set to the long range or people setting. Okay, we're ready to mount this. Go. Now, one thing you'll want to notice as my teammate puts that sensor on the rod is that he is rotating the face of it so that it is pointing toward the ground. Before we connect the sensor, we want to make sure that everybody is starting in the same place. Now, if you just powered on your xploer GLX, it will have automatically opened with a new file. But if you didn't, let me show you how to create a new file. We need to go to the data file screen, which is already selected for us up in the top left-hand corner. So we will push the check mark to open it up. You can see here that we can open, save, or delete files, but we're here to create a new file. So push your F4 key or button to open up your files menu, and you see the first item listed there is new file. Push the check mark to select it, and now you have a new file created. So let's go back to the home screen and connect our sensor. It can go to any one of the ports on the top, and you see that when we do connect it, the sensor opens up, or the xploer GLX automatically opens up with a graph display of position versus time, which we appreciate very much, but we also would like to see velocity on this graph display. So we're going to create a two graph screen for this display. So go to your graphs menu, F4, and you see item number 5 there, two graphs. Push the 5 to select it. So now that we have two graphs, position versus time and Y versus time. So we need to tell the xploer GLX what we want our Y to be, which is position. Velocity. Hopefully you remember that to change any of the measurements or units on your axes, you can do that by pushing or turning on your hotspots, which we do by pushing the check mark. To get to the hotspot that you wish to change, use your arrow keys. And then once you have that highlighted or shaded, push the check mark to select it, and you see there are a list of data sources. We don't want position. Let's check out what we have under our more selection, and there it is, velocity, acceleration. Let's push the check mark to select velocity. And now we've got position versus time and velocity versus time, and we are ready to collect data. So I'm going to push the start-stop button, and as soon as I do, or as soon as my teammate hears the clicking of the motion sensor, he will release the ball. Notice, before we start, that he doesn't have the ball any closer than 15 centimeters away from the face of the sensor, which is the lower end of the range of the sensor. Ready? Okay, and then we'll push stop to end data collection. And let me hit the auto scale button so we can take a good look at what we have here. So that information looks pretty good, but I'm willing to bet that many of you are missing some critical information around some very interesting events of the ball's bounce. what we can do to get a more complete description or picture of the ball's motion is to increase the number of data points that we collect. In other words, we need to increase the sample rate of the sensor. To do that, we need to go to the sensor screen. So let's back out by going to the home page and then go to the sensor screen by pushing the F4 button. All of the sensors collect with the sample rate unit of number of samples per second. Let me just show you something in this field really quick. I'll push the check mark to show you that you can actually change that to seconds, minutes, or hours between samples, so that if you're doing an activity like a weather experiment when you only need to get one data point every 10 or 15 minutes, this is where you would change that setting. Let me scroll down using the down arrow to the next field, which is the sample rate. You can see that the sensor is currently collecting data at 10 samples per second. You can push the plus or minus button to increase or decrease that, but we can also press the check mark to open a menu of items that we can select the sample rate from. So let's select item number 6, 50, to pump up the rate as high as it can go. So now we are sampling at 50 data points per second. That ought to give us a really good picture of this bouncing ball. So we'll go back to the graph display, but I want to show you a shortcut for doing that. If you simultaneously push the home key and the left arrow key, we can immediately get back to the graph display, kind of like using the back button in your web browser. So we're back at the graph display, and we are looking at a run that we don't want. So we're going to delete that run. What we need to do is turn on our hotspots again by pushing the check mark. And then we're going to arrow through our fields there, and you see as soon as we get to run 1, we can push the check mark, and under the menu there, we can select item number 3, delete run. And are we sure we want to delete it? Yes. Okay, F1. Okay, so now we have a clean graph display, and we are ready to collect a second run of data at a higher sample rate. Just at the end of the data run, I'm going to ask my teammate to actually push the ball aside so that we can get a measurement of the height of the sensor off the ground. And you'll see why we want to do that in just a moment. So are you ready? Okay. All right, let's take a look and see what we got. Okay, that's not bad looking data, but let me ask you one thing. Can you identify the place on the graph which represents when the ball hits the ground? If you asked your students to identify that spot, where do you think they would point to? My experience tells me that they usually like to pick the bottom part or the trough part of that curve, because they're thinking the ball's falling down, so it hits the ground when it's down. But if you take a look at our setup, we're measuring the position of the ball from the sensor, not the ground. So what we can do is perform a transformation on this data so that we flip the graph so that it's more intuitive. To do a transformation, we need to perform a calculation on our position data. To perform a calculation, we need to go to our calculator. So let's back out of the graph display by going home and then pushing F3 to open up our calculator. Now in the calculator you can do a number of things. You can use it like a regular calculator where you evaluate expressions. You can use it like a graphing calculator where you plot equations, or you can use it to perform operations on sensor data like we're about to do. What we want to do is define a new position of our ball H so that it represents the height of the ball from the ground, not the sensor. So let's start by defining H, and what I need to do to start is turn off number locks. So I push F4 to open my edit screen, push check mark to deselect item number 1, number locks, which is currently on. So now it's off. And now I can type in text. So I will use the multiple press text entry method to type in H and equals, Now, we need to know the height of the sensor from the ground, which we have. Let's go back using our little shortcut to go back to the graph. And if we look at where our data cursor is and the coordinates for that point, it is about 1.511 meters from the ground. So let's push home and then the right arrow key to go back to our calculator. And we will say 1.511, that wasn't it, back, 1, pause, 1, minus, and then we want to say the position of the ball, which is our sensor data. To tell the GLX that we are using sensor data, we push F2, or the data button, and select from our listed data sources their position, item number 1. So we'll check that, and then when we are finished with our expression, you push the check mark again to tell the Xplorer GLX that you're done. And our calculation is okay. So let's see what our graph display looks like now. And you can do that very easily by pushing the F3 button to turn on the preview graph. And if we move our cursor up so that it's on the line with our expression, we see now that our picture of our graph looks more like a bouncing ball.